Welcome to VTU Physics. In this video, we are going to cover the important concept module wise as per new syllabus, that is 21PHY12/22. With the help of you guys, I have reached 2K subscriber today. Thank you, and keep supporting, keep sharing with your friends, and don't forget to subscribe to my channel and press the bell icon so that whenever I try to share any kind of information related to engineering physics, you will get in the notification. With this, let's start the intro. In this video, I have covered module-wise important concept. If you are interested in a particular module, you can go to description box. There I have mentioned a timestamp given to the particular module. You can directly go to that module and prepare yourself for upcoming IA as well as semester exam. So with this, let's start with module number 1, that is oscillation and waves. In this module, we have 4 important chapters, that is free oscillation, damped oscillation, forced oscillation and shock waves. So let us start chapter wise important concept for 8 to 10 marks, starting with free oscillation. In this free oscillation chapter, you must study derivation of differential equation for SHM. This question will be asked for 6 marks, and along with this question you can expect the definition for SHM and give an example for SHM. If this question will be asked along with this derivation of differential equation for SHM, then this concept you can expect for 8 marks. After that, in the same chapter, you can expect mechanical simple harmonic oscillator, that means spring in series and spring in parallel combination derivation. This concept you may get 8 marks question. Sometimes 3 plus 3 you can get 6 marks question, or 4 plus 4 8 marks question. Okay, this is it for free oscillation. Along with this, you can expect some definition which may comes in free oscillation chapter, that is equation for equation of motion for free oscillation and natural frequency oscillation definition with equation. Next, that is damped oscillation. In this damped oscillation, you can directly get straight away 10 marks question or 10 marks derivation, that is theory of damped oscillation. Okay, this is an important concept in the damped oscillation chapter. 10 marks or 8 marks derivation straight away. Along with that, sometimes he may tell you to mention, not describe, mention with graphical representation overdamping, critical damping, underdamping. That means he may tell you to, by using graphical representation, explain or define overdamping, critical damping, underdamping. This concept you may get for 4 to 6 marks. That's it. After that, definition of quality factor. That's it from damped oscillation. Next, forced oscillation. In this forced oscillation, you must prepare, or you should not skip this derivation part, that is forced oscillation derivation. Okay, this is an important derivation. Along with this, and one more thing, important derivation for 10 marks. This is a very lengthy derivation. You can expect straight away 10 marks derivation from the forced oscillation. Next, along with that, sometime he may tell you to define a resonance and give an equation for sharpness of the resonance. This concept may arise for 4 to 6 marks. 4 marks for sharpness of the resonance, 2 marks for resonance definition. Okay, this is from forced oscillation. And let me tell you one important thing. In the free oscillation chapter, damped oscillation chapter, forced oscillation chapter, in this three chapter, you will get at least one straight away 10 marks derivation in the semester exam. So that means you must not skip these chapters. For example, in free oscillation, you must study differential equation for SHM and mechanical simple harmonic oscillator. In damped oscillation, you must study theory of damped oscillation. That means derivation of damped oscillation. In forced oscillation, you must study theory for forced oscillation, nothing but derivation for forced oscillation. Damped oscillation, forced oscillation, in these two, one question is compulsory. Along with that, sometime he may go to the free oscillation chapter also. Next one is shock wave. In this last chapter, straight away, most of the time he told you, or in the semester exam, he mentioned that construction and working of reddish shock wave tube. This is an important concept which we can see in the fourth chapter, that is shock wave. Along with this, he may tell you to define Mach number, mention the properties of shock waves and applications of shock waves. Mach number definition, properties of shock waves and applications of shock waves. Properties of shock waves, applications shock waves. You may expect 4 marks question each, and definition for Mach number. This is it from module number 1, and I hope you will not miss these below chapter which I have mentioned separately. If you miss this chapter or if you miss this concept, you can't be able to score very good in semester exam. So prepare yourself. Along with this, you can expect numerical problems from the Mach number or shock waves. In the shock waves chapter, you can expect 4 marks question to calculate the Mach number. Along with this, from the above chapter, you can expect calculate the K spring constant, angular frequency, time period. Along with that, damped oscillation derivation problems and forced oscillation derivation problems. For a problematic part, you can refer a textbook called Engineering Physics by S.P. Basavaraju, edition 2018 to 2020. You can refer this book only for problems. Please don't refer to some theory part is altered in previous syllabus. Okay, so just refer that textbook for problem solving, not a theory part. Okay, this is it from module number 1. From the module number 2, that is modern physics and quantum mechanics, this is the syllabus for modern physics and quantum mechanics. In this module, we can expect black body radiation spectrum definition. Along with this, we can expect 8 marks question to deduction of Wien's law and Rayleigh-Jean's law from the Planck's law. Okay, or sometimes he may tell you to reduce the Planck's law to Wien's law and Rayleigh-Jean's law for 8 marks derivation. Okay, sometimes he may combine this derivation with one definition. For example, define Wien's law or define Rayleigh-Jean's law or define Stephens-Boltzmann's law or define Planck's law. Only definition part, along with you need to write the equation for that definition. For wave particle dualism, in this chapter or in this main concept, you can get definition part for de Broglie hypothesis, and Heisenberg uncertainty is also you ask you for write down the definition, and 8 to 10 marks question is very important in this module, that is application of uncertainty principle, that is non-existence of electron in the nucleus by using relativistic case, not E equals to p square by m. You need to start the derivation E is equals to mc square. Okay, so specifically he mentioned in the syllabus you need to start the derivation by using relativistic case. So be prepared by using relativistic case. Next one is wave function. In this concept you must study the independent Schrodinger wave equation derivation, and along with this you need to study the particle in a box eigenvalues and eigenfunction, and that derivation is very lengthy, so you can expect particle in a box for 10 marks derivation, or time independent Schrodinger wave equation derivation also for 10 marks derivation. Sometimes in the last concept he may tell you to, by using case 1, when n equals to 1, n equals to 2, n equals to 3, find out the energy eigenvalues and energy eigenfunction and probability densities when n1, n2, n equals to 2, n equals to 3. In that case you can expect 10 marks question. Okay, so from the wave function you have three important concept, that is time independent Schrodinger wave equation, particle in a box, energy eigenvalue, energy eigenfunction and probability density, three derivation for 10 marks. Now in the case of wave particle dualism you have 8 to 10 marks question, that is non-existence of electron inside the nucleus by using relativistic case, and black body radiation, that is reduce the Planck's law by using Planck's law, reduce to Wein's law and Rayleigh-Jean's law. Okay, these are the important concept you must cover. Along with this, numerical problems, as I said, you must, or it's enough if you refer SP Basavaraju. Okay, problematic part only, not a theory. Let me clarify this one. This is it from module number 2. Let us see the module number 3, that is laser and optical fiber. This is your syllabus, laser and optical fiber. In the chapter laser, what are the important concept we must prepare? These are the important concept. First one is Einstein coefficient. There is a derivation which we need to give an equation for energy density, that is for 8 to 10 marks derivation. Along with this, construction and working of either CO2 laser or semiconductor laser. Okay, in the semester exam he will or he must give you write either Einstein coefficient derivation or construction, any one, either CO2 laser or semiconductor laser. Okay, so this is the important concept must be covered by you people. Sometimes he may tell you for 4 to 6 marks applications of laser in defense, for example laser rangefinder, medical application, for example eye surgery and skin treatment. These two concepts may arise for 4 to 6 marks. Okay, so these are the important concept you should not or you must not skip while preparing for semester exam. Okay, this is it for laser. Let us see optical fiber. In the optical fiber you must study the angle of acceptance and numerical aperture derivation. A very easy derivation will be there, you must cover those part. After that, types of optical fiber, by drawing that three types of optical fiber you need to explain the optical fiber. After that, attenuation, types of attenuation. Sometimes he may tell you to mention the attenuation, define the attenuation and explain the attenuation. In that case you need to give an answer for attenuation by mentioning it or explaining it. Okay, next one is block diagram of point to point communication, and this is an theory part, means you need to explain the point to point communication by using block diagram, and this question may arise for 6 to 8 marks question. Okay, by combining attenuation definition or numerical or acceptance angle definition, he may tell you or he may give you 10 marks explanation. Okay, after that, optical fiber sensors, this is the new concept. So that means he may ask you to write down the intensity based displacement sensor or temperature sensor based on phase modulation. Okay, so these are the two important concept: 4 plus 4 8 marks, or 5 plus 5 10 marks concept. Along with this, merits and demerits of optical fiber sensor. Okay, in the numerical problems, you can expect, or they can tell you to find out the attenuation problem, and in the case of laser there is no such problems are there, so let it be. From the optical fiber you can expect some problem. Okay, once again I would like to tell you, refer SP Basavaraju Engineering Physics from 2018 to 2020 edition. Only problematic part, please don't go with the theory part. 2, that is electrical conductivity in solid. In this module we have 4 main chapter, that is classical free electron theory, quantum free electron theory, physics of semiconductor, and dielectrics. From the first chapter, you can expect failure of classical free electron theory. This is an important concept in classical free electron theory. Next, in the next chapter, you can expect these two important concepts for 8 to 10 marks, that is expression for electrical conductivity and merits of free electron theory. Sometimes in the semester exam, he can combine these two chapters by saying explain the merits of quantum free electron theory and mention any 3 or 2 reason for failure of classical free electron theory. Like this he may ask you in the semester exam. So expression for electrical conductivity 8 marks question, merits of quantum free electron theory, that is also 8 marks question, failure of classical free electron theory, that is also 8 marks question. In the next chapter, physics of semiconductor, in this chapter you can expect conductivity of semiconductor, that is for 8 marks derivation, and very important concept, Hall effect, expression for Hall effect. This is also an 8 to 10 marks derivation, so you need to prepare Hall effect and expression for Hall coefficient. Next is dielectrics. In that, only one main 8 to 10 marks derivation is there, that is Clausius-Masuti equation. That's it. After this, you need to prepare for numerical problems. Once again, you can refer the textbook called SP Basavaraju by Engineering Physics. That's it for module number 4. From the module number 5, material characterization techniques and instruments. This is the syllabus for module number 5, that is introduction to materials, starting from introduction to materials. And in this chapter or in this module, these are the important concept which you need to prepare it for 8 to 10 marks. In this concept, they may ask you to write down construction and working of X-ray diffractometer, or construction and working of AFM, or construction and working of X-ray photoelectron spectroscopy, or construction and working of scanning electron microscopy, or construction and working of transmission electron microscopy. These are the important concept you must prepare in module number 5. As far as numerical problems concerned, you must prepare it by using Scherrer equation. Okay, this is it. As per 21 scheme, these are the important concept which I have tried to mention in this video. With this, we are going to sign off. All the best for your exam preparation. Before you are going to prepare it for engineering physics exam, don't forget to share with your friends, subscribe to this channel, and don't forget to press the bell icon. With this,